Hey, what's up? I'm Luca, and today I'm going to show you how I built this custom wooden Prism controller with a Sheikah theme from Legend of Zelda. If you're unfamiliar with Prism controllers, they are an offshoot of box controllers or fight pads. Their main goal is to offer a more ergonomic alternative compared to a standard controller layout. This particular design is Woonway's open source version, which is available on her Discord server under DIY resources under pinned comments if you scroll all the way down. I'll leave a full list of all of the tools I ended up using in the description of this video, but here is most of them along with everything you see here. These are all of the materials used in the actual controller, and I'll include them below as well. First thing needed is a flat surface that is decently durable as well as being able to be cut easily. This is some standard PLA filament as well as some MX switches and keycaps. This build uses a standard USB-C to USB-A cable as well as a USB-C to GameCube. Along with the wires, you'll also need some type of microcontroller. In this case, I'm using an RP2040 and a USB-C breakout board. After importing the templates from Woonway's server, I knew I wanted to have some Sheikah text running along the edge of the top face of the controller, and it turns out that this is available as a downloadable font, which is great. So as a little Easter egg, the runes actually say something along the edge. I will be the first to admit that this is the first time I've ever used this software before, and this took way longer than it probably should have. With the edges done, I found this nice concentric circle pattern which I think fits the theme nicely, and I just had to grayscale it for the laser cutter and then mask everything off properly. To finish up the top layer, I added the Hylian crest on one side and a Sheikah eye on the other. For the sidewalls, I found a slightly different Zelda themed pattern, and similar to the other ones, I just had to grayscale it for the laser cutter. And here are the finished designs. I'll be using a laser cutter to etch the patterns and eventually cut out each panel. Ignore the fact that it's literally in a bathroom. You could totally use like a saw or anything else to cut this out, but I spent $3,000 on this laser cutter and I need to validate my life decisions. So once I have my computer plugged into the laser cutter, I just need to add the wood, and I'm pinning down the corners with these little L-shaped pieces. This is just so that everything stays flat while it cuts, as materials with internal stresses like acrylic or wood can flex if they're not pinned down. Now we can get to actually etching and cutting the wood. You can see with this one I accidentally didn't cut all the way through, and I had to run an exacto knife along the edge, which was super fun. Now on to cutting out the front piece, which is just a really big triangle. And okay, so I found out that my camera only records 12 minutes of video before it just shuts off. I missed the time lapse for this portion, so go ahead and just use your good old imagination of what that pattern looks like and eventually cutting out the exterior so that way it looks something kind of like this. Not gonna lie, this whole process took way longer than I thought it would. This footage is literally at 10,000% speed, not to mention the difficulties of actually recording in this laser cutter. Moving on to cutting out the faceplates was honestly when I started to get pretty excited about the actual build. However, unfortunately, I had to redo both of them as there's a line through the eye on this one, and for some reason on the right side, half of the holes didn't actually get cut out. So I'm sanding the edges with 800 grit sandpaper to remove some of the burnt residue from the laser cutter, as well as the sharp edges from the pieces that didn't get fully cut out. And here are all of the pieces once they're sanded. I'm honestly really happy with how all of these turned out, and now I just need to get to assembling everything. I made a quick mock-up out of cardboard so I can find the internal angles, as I plan to glue the panels together with various wedges, as I didn't want any visible hardware like screws on the outside of the controller. Normally I'd use an angle finder for something like this, but unfortunately I don't have one, so I ended up using a protractor, which was rough, but it ended up not really mattering anyways, as when I printed out the angles, they were nowhere near the actual angles, and I had to resort to just good old guess and check at the end of the day. Here is a look at the 130-degree wedge. You can see it put the number on the front of it with the angle at the top. And I'm very glad that I decided to put the numbers on the front, because trying to decipher between 130 degrees or 125 degree wedge without them labeled is much harder than you'd think, so. I ended up printing out a couple of each of the angles as I wasn't exactly sure how many I would need of each of them. I'm using a small dab of hot glue to connect the wedge to the wooden panel, and I'll be using this trick where if you hold the piece right out of frame, the glue actually sets up around 20% faster, and you'll see me use this tech several times throughout the build process. So, here I'm gluing the top panel together with 3 of the wedges. I'm gluing the top 4 panels together as it'll provide a lot more structural stability while I hand solder the buttons, which is the next step after this. So the original plan was to reuse low-profile kill switches and keycaps from previous projects, but for some reason the keycaps only fit with the original switches, which means I'd have to desolder them from the keyboard, as they don't lock into place and have a ton of play with the ones I bought. I ended up switching to MX-style switches and had to make a last-minute trip to Micro Center to get some MX keycaps. With all that sorted out, all I needed to figure out was which keyboard key matched up best with the button on the controller. I'll throw up a layout on the screen to make it easier. This ended up being a bit more difficult since each row of an MX keyboard has a different shape, and I wanted to make sure that I could easily slide between buttons. And this was the final layout I came up with. Next was gluing the switches in place, which I used a hot glue gun for. I debated about making a quick PCB so it could be hot swap, but part of the challenge of this build was to use only stuff I had accumulated from previous projects, which I succeeded in, except for the keycaps. Stupid keycaps. In a kind of backwards way, I found it was easier to solder to MX hot swap sockets rather than the pins directly, so I put those on despite the switches being glued in place. This does mean I could theoretically swap out the electronics in the future if I wanted to, but no shot, I'm never doing that. Now comes the part of soldering everything together. This is called daisy chaining, where you connect one pin from all of the switches and then connect that to ground. As with the case for the microcontroller we'll be using, the inputs are pulled high, so buttons are considered pressed when the input is shorted to ground. Not too shabby. This is the diagram used for hand wiring a controller with the Pico. It's available on Cranes Labs Discord, which is an excellent resource if you want to build your first box controller. For soldering most of these wires, the easiest way is to loop the wire around the hole in the pad and then add solder after. And you just do that for all of the connections that were shown in that diagram. Soldering the D+ and D- pads for the USB port is a little more difficult since you're technically soldering to test pads that aren't meant to be used in this way. Also, it doesn't help if you're using a terrible soldering iron. But we get there. Now comes soldering the other pin to each of the switches to its respective input on the Pico. This is just a lot of measuring lengths of wire, aiming to have them all converge in the middle. It's way better to have the lengths of wire too long than too short, although I made a lot of these way longer than they needed to be, but hindsight's 50-50. I 3D modeled a mount for the USB-C breakout board. I don't have any footage of this, so here is a video of someone 3D printing a gecko instead. Then realize that you measured something super wrong and have to cut the breakout board down to size so it'll actually fit in the mount that you made. Don't touch me. All that's left is to glue it in place. I then used 2 M2 screws to hold the breakout board in place. For the pieces that didn't fully get cut out, I used some wire cutters to remove the excess and immediately broke off a corner. So nice job with that. But it's okay, we can just fix that with a little dab of hot glue and struggle to pick up the piece from the table and then use that classic technique of holding it right out of frame. Since the wood isn't perfectly flat, a lot of the pieces were a little warped, as you can see here. So the corners weren't fully aligned, and I had to glue each corner in place and then hold it like that for what felt like 10 minutes for it to set up. And if I let it go too soon, then it would just pull apart. Just look at all that fun I'm having in this clip. The last panel I had to glue on was the backside, and then instantly I realized I had a problem. This whole project, I had basically been pushing all of my imperfections from the top to the bottom of the controller, since the panels are warped, coupled with the fact that I was kind of guessing with some of the internal angles. The original base plate doesn't fit at all. It's hard to see in this footage, but it's way too long in one direction and too short in the other. So because of that, I did my best to measure the errors that I would need to correct for with some calipers so I could recut the base plate. Once I had made all of the edits, all I had to do was just cut it out one more time. I wanted an easy way of removing the base plate in case I ever needed to access the insides, so I'll be using some of these small neodymium magnets with some little 3D printed pieces glued to the bottom of the inside of the controller that are lined up with magnets on the bottom panel. Lastly, I added some rubber grip pads to the bottom so it wouldn't slide around when using it or scratch the surface it was lying on. And here are the final results. I'm honestly super happy with how it turned out. I've built a ton of box controllers in the past, but this was my first Prism. I really like the Sheikah theme. I think it came out super well, especially on the wood. It's definitely more of an art piece than something I'd bring to a tournament, as it definitely is a bit fragile, but I'll probably try to find some nice keycaps as well. I don't love the Japanese ones that I found, but it was this one or German keycaps, so I think I made the right choice there. But if you want to build your own Prism, please check out Woundway's Discord server or Crane's Lab for more general DIY controllers. Or lastly, if you want to check out my own Discord server, I'll list them all down below. I'm not sure if this is something people would be interested in buying. I'd first have to check with Woundway to see if she's okay with it, but I'll leave a Google form down below in case this is something I consider in the future. They probably would have to be over $500 just given the sheer amount of labor that goes into each of them, even with a redesign. But who knows? If enough people are interested, maybe. Anyways, thank you for watching. All right, bye.